Yes, thank you very much. So thank you very much. That's about those we can take. So please, like I did said, we are going to be using some of our recorded materials, recorded sessions for this class. So stay tuned. The training is going to be very, very engaging. So please, your questions, you keep it to the end of the class. You can drop it in the in-message session, but trust me, after the class has come to a end, we'll give time for you to ask your questions. So once again, I say thank you and welcome each and everyone to tonight's class again. So the next screen you'll be seeing will be that of the training class. So please just let me know if you can see my screen. So please, can you all see my screen?
Yes, I can see.
Okay, thank you very much. I really appreciate that. So right about now, the training session is going to begin. So please, like I did said earlier, let us maintain decorum. Ensure your microphone is on mute when you are joining the class. If your microphone is not on mute, you will only be kicked out of the class. So let us do this, and we'll have a nice time with ourselves in this training session. So thank you very much. The training is going to begin right about now.
All right, thank you, Mr. Kende. Good evening, everyone.
Good evening, sir.
Yes, you are audible. Yes, am I audible?
Yeah, you are.
Yes, you are.
Loud and clear. Thank you so much. I know Mr. Kende has done a lot of introduction, being a moderator. I really appreciate you, sir. Thank you so much for bringing me on board. And I think that going through the in-message session, I can see that we have few people, okay? Few people who have actually taken our training before. So I want to appreciate you a lot for choosing us all over and over again. Now, I want to buttress what Mr. Kende has rightly said. That's talking about the training that we have at hand is a very elaborate one. In fact, I must tell you that if people really understand what we are trying to achieve with this training, in fact, this platform shouldn't be enough for us. We should have thousands and thousands of people practicing in the field of manufacturing, construction, across every industry that we can link to engineering field. So I would actually expect everyone to be on board because it is a course on its own. In fact, the certification that comes with this training, it's something that it's in fact, it makes you, it gives you like an isolated career. Let me use that word. Like just is a career on its own, even without you connecting it to what you are doing presently now, because maintenance is engineering. Engineering is maintenance. And in this part of the world, I think that we don't really have that orientation, good orientation about maintenance. I'm trying to say that our maintenance culture is not really that solid. It is not that prioritized, and that's why many people may not really know the damages we are doing to our industries because of our poor maintenance culture. So we have industrial machinery maintenance. And what we're actually doing with this course is just like we are discussing, productivity across every form of industry. We are discussing functionality. We are discussing reliability. we are discussing equipment availability. So paying attention to this training and being on board from the beginning to the end can guarantee you to be an exceptional, worker across in any applicable industry where you are in. So let me take my time to share my screen. Okay. So I'm sharing my screen now. I want to go on to the in-call messages. So we have people saying, I want to gain practical experience on machinery maintenance, different from the usual theory. Good. Machines in general, knowledge of machines in general. My expectation is to advance my knowledge on industrial automations. Okay. My name is Afolabi. Afolabi, you didn't tell us what you really want to gain from this class. So I'll put all this together, and I can tell you that they are not really far. Okay. In fact, they are just little to what we'll be sharing on this particular course. So as introduced, my name is James Fanny, and then I'll be on board with you. Thank you so much. Somebody is clapping for me already. We're just starting, but thank you. I appreciate that a lot. So let me first tell you how bulky, explanatory, and detailed our material is. Trust me, this material is a material that on industrial maintenance, I want you to search the nook and cranny of the internet, okay? You would come to realize that what we are sharing with you is actually what go. I'm here with you, sorry. So let me see you raise your hand if you are working in any industry. Like if you are working across any industry, just raise your hand. Just signify by raising your hand. Can we hear me still?
Yes, we can hear me. We can hear you. Please go ahead.
Yes, we can hear you.
Okay, so I can see people.
We can hear you.
Hands. Okay, moderator, can you help me to please call people, like 2 people at random? Just call them, pick them up for me. I want to ask some questions.
Okay, Akitono Akinwale. Akitono Akinwale. Kindly unmute your mic. Akitono, sorry. Akinwale. Yeah, Akitono Akinwale. Yeah, that's fine.
Hello, can you hear me?
Yes, I can hear you now.
Okay. Sorry, I'm on the road. I can hear you.
Can you speak freely, or we should call another person?
What is the question?
Okay, so just listen to the trainer. Just listen to the trainer. He has some questions.
Okay.
Just tell us the industry where you work in. Just tell us the industry where you work in and tell us the machines that you interact with.
At the moment, I work with a plastic company, that is packaging company. And we have a extrusion machine and cutting machine. So we deal with SDP and LCP, and also the recycling of those materials.
Thank you so much, sir. Thank you so much.
All right.
I'm going to do another person.
Okay, 10 years. Can you hear me? 10 years.
All right, I can hear you.
Okay. So
just follow the same thing that I asked the first person.
All right.
Where your industry, which industry do you work in, and the machines that you interact with?
Okay, thank you. My name is Waribo. I previously worked in the power industry as a power plant, in power plant generation segment, where we build a power plant using gas generators and then turbine of medium sizes. And then I later moved to the oil and gas where I would do power plant construction. And then now moving to the facility maintenance industry, mainly operational maintenance. Thank you.
Okay, thank you so much. Any lady among those?
Hello, good evening.
Okay, that's fine. Good evening. So,
Yes,
which one industry you working in?
I'm working at NOV Limited.
Can you come again?
Can
Can
you
you say that again?
NOV Limited.
So,
what are they into?
What
what do you guys do? Yes, machines
repairing
that
of
interact with.
vessels. Okay. I'm not working with people that are using other machine. I work in an office. I work with I use AutoCAD. I'm in architecture. So can you hear me?
Okay.
Yes, please. You can.
Yes.
Okay.
I'm in architecture. I don't work with
That's
machines.
okay. That's okay.
Yes, sir.
That's okay. So you are just familiar with the machines.
Yes, I used to go on dock.
Yes.
Maybe to supervise.
Familiar with the machines, not that. Yeah.
Sir?
Yeah. I get the nature of your job. I understand. I understand the nature of your job. I understand.
Yes, but I used to see some machines inside their workshop.
So, Mr. Moderator, thank you so much.
Okay, thank you. Yes, sir.
Okay. All right, thank you. So let's move on. Let's move on. So please, I hope everyone can see my screen.
As you can see, though very so tiny.
Yeah.
You can still see.
You can see the so tiny.
Thank you so much. So let's first look at industrial machines. Let's look at some industries and let's explore the kind of machines that they actually interact with. So we'll now come back to really explaining what maintenance is all about, and then we introduce the course, and then we see how far we can go tonight. So
please, before you material, go ahead, sir. Can you make your material in the landscape form? Can you hear me, sir?
You mean this is not feasible?
It's kind of not visible. Yes.
You mean this is not feasible?
Okay. That's fine. It's fine now.
It's good. Is it better?
Yeah, it's better.
Okay.
Thank you, sir. You can go ahead, sir.
So, all right. Okay. So let's look at the material handling equipment. So where we have cranes, we have forklifts. Of course, we know what cranes is used for. Crane. We use a crane for lifting and moving heavy materials. So I was actually asking also that I will know some set of people that we have here, but so we know what forklift is being. You can use forklift in within a workshop, just to move material from one, just like transporting material within the factory. So from one spot to another, we have machining tools. And of course, there are some industry that use conveyors. Let me show us the picture of some of these. So this is an example of crane. Okay, this is a crane. So it is used for so this is forklift. So when I'm talking about it, you can relate with what I'm talking about. So this, you must have seen this, or maybe they make use of it in your factory also, just to move, transport material from one spot to another. So I make mention of another one is conveyors. hardly will you see any product manufacturing company that do not have conveyors. So conveyors, you know, they are being conveyor belts, or you can, some of them are like in chains. So you will see them in production line to move material, okay, transport material, you know, from the, either you are from the packing plant to the what loader, or to the vehicle where you want to actually what load it in. Let me show us an example. So this is an example. If you have been to airports before, when your luggages are being brought, okay, so they actually put in what? In conveyors. So, and in your factory also, you must have seen this. This is an example. So you can see some of these materials on the belt. So the conveyor belt transport them from the packing, you know, spot to the loading what spot in most cases. So it is being used to what move material from one spot to another. We also have machining tools. Some of us must have seen this before. Computer numerical control. So they are used for precision cutting. Okay, when you want to, you need a very great deal of accuracy, you know, in cutting or metals or plastic. You know, some of them are also used for drilling, for shaping materials. Let me see if I've got you a picture of that. Okay, so this is an example of CNC. Okay, so you can see some of them, they are being used to actually what kind of drill. You use some of them for cutting. Okay, these are examples of such machines. We also have lathe machines. We have, you know, milling machines. Most of us across higher institutions, I know the common machines in the lab is also is always lathe machine, especially for the mechanical guys. So we have welding machines. We have press brakes machine. I think I showed you an example of I have a picture of press brake here. Let me show you that. So this is a press brake. Okay, this is a press brake. So you use it to what? To press a metal into desired what? The metal sheet into desired shapes. So the shape that you want, you can actually use those machines to what? Press them into what? That particular what? Shapes. We have cutting machines. Okay. We have power generation equipment, like the one that my friend that came up to talk about that is working in a power plant. So he will actually be familiar with what? A lot of that, talking about the turbines, okay, for the generation of what? Of power and all that. So we have pumps and compressors. And will you see, you know, in an automated plant where you don't have compressors? Because when you are making use of pneumatic systems, or there are some machines that are powered by what? By air, which is what pneumatic what system or pneumatic power generation. So you will have what? Compressors, okay, which actually what produce the compressed what? Air or pumps. So most of us must have interacted with some of these as engineers, especially if you are working in the electrical what? Aspect of the company. We have packaging machineries. So these are used for packaging. For those people that are working in companies where they, you know, they have to label the products, they have to put them in can and all that. So we have filling machines. So this one actually was autofill, you know, the content into the containers. If you are working in bottling companies like Coca-Cola, you know, Pepsi, so you must have interacted with some of these machines before. So filling machines. There are also labeling machines. So these automatically what? Put labels on the products, okay? So these are, you know, for us to actually know how broad the course we have at hand is. And definitely, I must tell you that no matter maybe your own aspect of work, you know, in your own company, in as much you are interacting with machines, even though you are in care of what automation and all that, this course is actually what it actually gets you covered. You know, it will actually what open your eyes to so many things, you know, about maintenance, and also get you, you know, trained and prepared to be a better to engage in a better maintenance culture. So we have every we have a sealing machines also. Those ones, they actually use to actually what? Seal. Maybe you are working in some people that have worked in such a water company before that we call pure water, pure water company. So, most of those nylon, the machine that seal it, that close the mouth, okay, we call them what? Sealing machines. So they make use of what? Heat. So it's through that way to apply heat to what? Those nylon and then what? Cut them. I've worked in a pure water company before, so I can actually tell you so much about what? Sealing machines. So we also have heavy construction equipment like excavators. Most of us must have seen these before. We have bulldozers. I think I have pictures of excavators here. Okay, so this is an excavator. Okay, this is an excavator. So it is used for digging and moving large amounts of what? Earth. So that's excavator. So all these machines, they would not function well, or you will not have their reliability or an accurate reliability on them if the maintenance is not being put in place. So it is the maintenance of all these machines that we actually looking at. That is why you see the course being tagged industrial machinery maintenance. So we have bulldozers. So those ones, they are heavy machines for pushing large quantities of soil. So you see that as some people will still call it loader, but when you see a bulldozer, so this is an example of a bulldozer. So you use it to pack. While excavator will dig the earth, this actually pack it. So it pack it. You can see that a bulldozer is actually look at the arm, it's shorter. It's just for you to pack what you have already dug out, and move it from one spot to another. So, but when you see a loader, how you will differentiate a loader from this is that you will see the arm of a loader being long. This is a loader. So this is the one that will now be taking it and be loading it into truck. Let's say you want to load into truck, or you want to pack it all in a spot. So you see this. This is a loader. Okay. These are examples of loader. So we also have machines, the robotics and automation equipment. So industrial robots, we have AGVs. Most of us must have, seen AGV just like in video, but yet there are some industry that make use of this. They are just mobile robots that transport materials in warehouses. So you can use them without human intervention. So, human can complain that maybe they are tired. You see that, or maybe it's not really that effective using humans, to pack those things and to move them from one spot to another. So you can actually use AGV, okay? And definitely as human being will say, I want to go on break, I want to go and eat. This machine will not say so. But if you put their maintenance, okay, you give them proper maintenance, that's where you can actually have a good reliability on them. So these are examples of AGV. So you can see they move materials from one spot to another in the industry. So you can see these are examples of them. Some of them we even load. These are examples of them. So we also have, for you to see, I'm actually kind of going through different industry now. So you can see that no matter maybe the industry, I will ask you a question. If your own industry has not been covered in some of the examples of the machines I've given, so then you can actually signify. Then I can extend it to that when I'm taking the training. So we also have a HVAC equipment that we call heating, ventilation, and air conditioning. So these are HVAC equipments, okay? So we have industrial boilers, we have industrial air conditioners, okay, under these categories. So let me show you an example of HVAC. Most of us that, maybe there is a unit in your company that deals with chilling of that place has to be chilled, like it has to be very cold. We call it central AC. Back then when I was working in Obajana, so we call it central AC. So it's not like the way it's centralized. Let me show you. You might have seen such before. So you can see this. So this is a cooling system. Okay, it means that what that particular place has to be very, very cold. Or if we are into products that they have to be produced at a very, very low temperature, almost what a frozen temperature. Or they need that cooling effect for them to be preserved or for them to come out fine. So you have some of those equipment, some of those machines. We have agricultural machinery like tractors, like combine harvesters, like irrigation systems. Okay, those are also machines across agricultural sector. We have printing and textile machinery. Okay, printing presses. Even if you have not seen this before, you must have heard about what printing press before. So machines, printing presses, those ones that produce they produce or printed materials in large quantities. Textile machinery, food processing machinery like mixers and blenders. For those people that are into even small scale baking here, they will be able to interact with what I'm talking about, even though you are not doing it in a large scales. So we have mixers, we have blenders, all these must be maintained. We have extruders. Extruders are used to, when you want to create some product that you want to shape, you want to bring them out in a particular shapes. Those are the work that our extruder does. Maybe you want to produce something like pasta, some snacks and all that. I think I have a picture of an extruder here. Okay, this is an extruder. Okay, this is an extruder. Okay, this is an extruder. So you can see this. Okay, look at this. So there are some of your, if you see some biscuits that or some chocolates that they will come out in a particular shape. Okay, maybe all of them are forming V or something like that. There are some of them that it is just the work of extruder that produce them like that. Or you want to have them being flattened. So some of these is being achieved by extruder. So those who are into food processing will understand what I'm talking about. We have pasteurizers. Okay, those ones they are used to eliminate pathogens. Okay, in food and beverages, so that when you store them, they can actually stay for a longer time. So pathogens are like bacteria or viruses that can actually spoil that particular product. So when they produce that particular food or beverages, they have to use a pasteurizer to just eliminate some of the pathogens and extend the lifespan of that material. So this is what we have. I've just taken my time to go through some of the machines so that everybody going through this training will know that they actually covered. So let me ask us this question now. If you know that your industry is not covered, can I see your hands up? A doubt. Or perhaps we may have anyone here whose industry. Oh, thank you so much. I'm apologizing before the moderator will even call you to speak. I'm already apologizing. Thank you. Don't worry, maybe it's just not just cited, because this is just to give us like a brief and overview of machines, but I will allow you to talk.
Okay, Swat Kushi. I hope I didn't murder that name. Can you unmute your mic? Okay, thank you very much. Good evening. Are you speak up? I can't hear your voice. Okay, you are sounding quite far away. Nevertheless, if you can hear me, just so what industry do you work in rather? Okay, yes, you're audible now. You're audible.
Can you hear me very well now?
Yes, we can hear you.
We can hear you. I can hear you. Huh? Okay, I can hear you. The area is the renewable energy engineering actually, and when distribution of those energies, we normally use control panels, and that's the area I was expecting for him to mention. And
And the control panel deals with control of the automation of the breakers. So that was the area I was expecting him to mention, which I didn't hear.
Okay, that's the aspect of the automation aspect. I guess you correctly.
Yeah, thank you so much. Can you hear me?
Yes, we can hear you.
Can you hear me?
Yes, we can.
Okay, thank you so much. Yes, I actually mentioned automation, you know, as a category. But if you look at all the other aspects of engineering that I mentioned also, there's no way we can exhaust all their machines. We are just listing like 2 or 3 machines. So if you are talking about automations, you talk about PLC, which is part of the, you know, maintenance of PLC is part of the thing that we are going to cover. So programmable logic controller that is actually being used to really achieve automation across industry. So of course, we can't talk about automation today without mentioning what PLC. So that's taking. Thank you so much for bringing that up to my notice. Okay, so you can see me. I'm actually I'm using a drawer account just to like back up in case, you know, any of my account actually go off, so that there won't be any break in our transmission. That's why I'm actually doing this. So if you can hear me, let's actually move on. Let's move on with the training. So we have extensively discussed, you know, the industries and some machines across this industry. Now we begin to actually talk about the principles of machine operation. What is actually the principle of machine operation? Because it's very important for us to really focus on this. So if we understand the principle of machine operation, so it will help us to really value or understand better what we are discussing in this particular course. So there are what we call pre-operation checks when it comes to maintenance. There are what we call pre-operation checks. But before I go into that, I think we should have some analysis, you know, of what maintenance is. Maintenance actually helps us to keep the machine in good shape. Maintenance is necessary in industrial machineries so that our machines can actually be kept in a good condition. Maintenance is necessary in industry so that we can achieve reliability, a good reliability, and a good availability on the machines being used. Don't forget that one of the greatest enemy across every industry is downtime. In fact, I remember then that anytime we want to do a money briefing, you know, in one of the industries where I've worked, okay, I've worked in so many industries, I can just be using the example when it comes up. So one thing they normally tell us is that, you know, our GM, we address us this way that, okay, you are welcome to work today. I hope you guys are doing great with your family. So today we have an enemy facing us, and this enemy is downtime. The enemy of production or effective production is always downtime. And what is downtime? Downtime only occurs when our machines pack up, when there is a machine failure. And in most cases, the failure in machines are really being caused by our failure in the aspect of maintenance. Maintenance begins even domestically. And that's why you see that as a maintenance engineer or a maintenance employee, okay, if you find yourself in the maintenance department and you have a poor maintenance culture, definitely is going to actually affect the way you carry out that job. Judging from the way some of us maintain our gadgets, the way you maintain those things that you have, maybe you have just 2 or 3 pair of shoes, you know, the maintenance you carry out on them, how you take good care of them, that even people may not even notice that you do not have more than 3 shoes. But there are people that they can have even 16 pairs of shoes or 20 pairs of shoes. And trust me, the way they will use all this, it will not even amount to one. And you will see somebody with just 2 pairs or 3 pairs, the maintenance they carry out on it, the way somebody was telling me one day, relating with me, the friend, and was telling me that he was showing me the shoes. He said, this is my party, one of my party shoes, and that he doesn't have more than 3 of them. That as he's getting home right now, no matter how tired he is, he has to remove the shoes. He will clean it, no matter how tired, and make sure that what he places it where the odor and everything, there will be some ventilation on it, so that it will be in good shape in case you want to wear it the following day or anything whatsoever. That's a good maintenance culture. Okay, so when you translate this into industry, you will see some people, they will handle a particular machine, place the machine under them, and then you will see that machine in good shape. And the same machine being handed over to another person, you will see that the machine is already in bad shape. In most cases, people blame the manufacturer, whereas most of the problems comes from the operator or the maintenance engineer that is in charge of it. If you are not exposed to this line, let me first tell you that when you are working in industry, there are people we call operation, workers, and there are some people that we call maintenance workers. I've worked in both departments. I will call it a department, but it's not really a department like that. If you have electrical, for example, let me give you an example. If you have an electrical department in some industry, you have electrical department, you have automation department, you have a mechanical department, you have process department. So there are some industry that have more than that. I'm just giving you an example. So in electrical department, take for instance, there will be some of the electrical personnel in charge of maintenance, and there will be some of these electrical personnel in charge of operations. What does the operation actually do? Operation is that they are the one operating the machines, so that we can meet up with daily operations. What is the maintenance guys doing? They are the one ensuring that the machine are in good shape, so that they can perform what the operators want to use them to do. I hope we are actually following on the training. Somebody talk right now.
Yes, we are following.
The operators.
Yes, sir.
Okay, thank you. The operators operate the machines. The maintenance guys, they put it in place. They put the machines in place. I will still talk about, there are some, kind of maintenance that the operational guys also perform on the machines. In the course of the training, I'm going to actually briefly talk about that. Now, let's now go back to it. Now that we understand what maintenance is, that it's actually the focus of maintenance. Forget about theory or anything whatsoever. I always tell people, you're not coming here for me to be telling you what is maintenance or what is this. That's not why we are here to actually bring this to the practical application. And we must use the simplest terms to explain what we are talking about, and not to blow grammar. So what maintenance is focused. Maintenance is focused at putting our machines in good shape. And most times you will think that it does not have effect on you as an employee, but that's a very, very big lie. When a machine is not in good shape, aside the fact that the company is actually losing based on downtime, you are in a greater risk as an employee. Your life is at risk, and even the life of fellow employees are at risk. That is why performing a good maintenance on machines does not only favor the company, but it actually favor you, aside from the integrity, aside from your personality. What about the safety aspect of it? Of course, the MD will hardly come and interact with this machine. You and fellow employees are the one touching it, operating it, doing one or two things on it. So the effect will actually be on you. Now, let's start with pre-operational checks. What are the pre-operational checks? Pre-operational check that is actually telling us on things to do before we actually a machine begins what to operate. What are the things to do before a machine begins to what operate? Maintenance starts with what? Pre-operation checks. Now, the first thing is for you to be able to read and understand the machine manual and safety guidelines. And this is what I will tell you that an average African person, you know, sometimes, many times, with few people that I've known, okay, even for somebody like me, at a point, I have to just what adjust. I would tell you that it took me a long while before I could read the manual of my car. That is when I knew that, oh, there is a great danger you can do to yourself when you're using a machine without going through the manual. Many of us, we do this a lot. Only will you see a machine that when you unpack it, you will not see what the manual there. What do? We throw the manual what away, and we try doing what trial and error on the machines. But in the manual, you will be able to actually what know the machines and know the prescriptions and the recommendations of the manufacturer. So no matter how simple the machine looks like, it is very imperative and important for an operator, somebody that will interact with that machine, to really have access to reading the manual and ensure that what he understands the manual. Of course, in the manual, you will have what the part of the machine being labeled. You will see the functionality of the part of the machines, and you will see clearly the kind of maintenance you have to carry out. So the pre-operation check is very important that what you read and understand what the machine manual and safety what guidelines. You see that how to safely what use the machine will be what specifically what mentioned in the manual. Another thing is that it is very good that the person that will operate this machine should be properly what trained, and it should have what an authorization to operate that kind of machine. In your factory, a machine that you are not the one, you know, you are not the operator of that machine, or you do not interact. Like my friend that said she worked in the you know, her work is in the office, like to control, but sometimes she only moves to field to go and inspect what they are doing. Her work is not to operate. Her work is to actually what inspect or check if they are working, and if this machine or the other is actually what you know, functioning. That is what she needs to actually what do. So you are not to interact with a machine that you are not trained on. I watched a funny video of this comedian. He was trying to work on you know, some wire. He wanted to connect them, and the father called out to him, say, won't you wait for an electrician? Say, Dad, am I not an engineering student? And as he was just speaking, the wire just what the light touched the neutral, and he had a very big spark, and he went transfixed, and he was like, oh, Father, I will wait for the electrician. So that's on a lighter note. But what we are saying is that what you are not to interact with a machine with, you know, just being overconfident that what you can operate it. So if you are not trained, do not. So we need to train the what operator of the machines, and it needs to get what the correct what authorization. Before you set a machine into operation, please conduct a visual inspection of the machines and its components. Even if you have used that machine yesterday and you are to operate it today, conduct what a visual inspection. What do we say a visual inspection is? Visual inspection is just that you have not even powered the machine. Go round. It's just like people that drive and park their cars where children plays a lot. God forbid, I've seen some of those funny, you know, pictures. You see some children very funny. You just go under the tire. That's where it's actually what playing. So imagine if you do not carry out a visual inspection before you. Some people just dash into their car like that. You don't go around to know whether some people are behind the car or a baby is behind the car that what your mirror cannot sight, or somebody is standing at your blind spot. We call it blind spot in driving, that you cannot see. You do not look around that place. You just start the car and then you zoom. Just imagine that kind of horrible incident. God forbid. That's exactly what it is like when you do not conduct what? A visual what? Inspection. For those people that did, our safety training, I gave you an example of a very, bad incident in a particular what? Company. This is a life story. The operator came, resume work in the morning. This is a company where they do not work all night. So they will close, and then the following morning they will resume operation. So, and there are some industry that normally attach a machine to a person. Like, you will know that this is your own machine. You are the one operating this machine. So the operator did not, when he was entering, his machine is actually far from the entrance. But for many of us that actually operate machine, I want to really explain how the control, the push button actually work. There are sometimes that when you are, they will make it available that on your machine you can start your machine. Like, there are ways you can start your machine when you are with the machine. You can also remote start the machine. Like, there may be a push button far off that you can also use to power up the machine. So the man did not go to where the machine was to actually inspect it, to carry out this visual inspection that we are talking about. He just power up the machine. And unfortunately, the cleaner was actually at the machine, cleaning the machine. And her head was directly under the cutting blade. She died. That was a very terrible story. So the purpose of conducting the visual inspection is for you to actually see some physical damages, and for you to see, the dangers to the safety of even you yourself that want to operate the machine. So check for any damage, wear, or malfunctions on the machine. Even before you actually set it into operation, you have to check and be sure that okay, the machine is actually in good shape. And then make sure that all the safety features are also functioning properly. Many people like this a lot. They jumpstart everything. They will say bypass. That's the terms across industry. When you say this thing has spoiled on this machine, you say, okay, can you bypass it? Can it still work? Okay, it can work. You bypass it. So you bypass almost all the sensors on the machine. So what will alert you when the machine is not in good condition? It's just like your body system. That is how machines are. Machines are built like human body system. Okay? Your brain is actually there. Your nerves are actually there to alert you that something is going on. When it is not well with your stomach, you have to have what we call stomach upset or stomach ache. Your brain will actually sense it and will let you know that there is a trouble inside your stomach. When somebody is talking, your ear will pick the signal. When something is smelling, which could actually be a wire burning in your house or anywhere, your nose will give you the trigger. Okay? When something is hot that you must not touch, if your skin touch it, you will actually feel the sensation. So these are the sensors, sense organs in your body. Likewise, in machine also. You have a thermostat that is not working properly on the machine, they say bypass it. You have a proximity sensor that is not working on the machine, you bypass it. You have the pressure gauge that is not working on the machine, you bypass it. So what we tell you, when the pressure is too much in the machine or when the temperature is too high, how are you going to know as a worker? So all these are, pre-operation checks that must actually be carried out on the machine. Now, the next thing for us to discuss is the safety principles. The safety principles of machines. You need to know that it is wrong for you to operate a machine without knowing the hazards that are attached to that machine. This is part of the things that will help you in your maintenance culture. You need to understand. So it's just like you going to war without knowing your opponents. You need to be able to know your opponents or know your enemy's strengths and weaknesses. So when you are working with a machine, this is not a human being that perhaps if you want to cut your hand, you say, please, don't cut my hand. And the person can stop and say, oh, sorry, I didn't know that your hand is there. It is a machine, for crying out loud. So working on a machine without you as a person knowing the hazards that are attached to that machine is against the maintenance culture across industries. Unfortunately, what I'm talking about might not really be something that you are seeing in your your staff handbook or your GM is telling you, because I will tell you that what many of our industries will focus on just getting the results, whether you put your life in danger or not. It is only those companies that care so much about their reputation that will actually will deal with you, or perhaps sanction you for not following what safety protocols. Some companies will look away in as much you are giving them the result. If you like, use your hand as the burning, as the fire. In as much what the product will burn and everything will be okay. Some company may actually look away. But trust me, you that know that what this aspect I'm talking about as a machine, this aspect of a machine affects you directly. If you are interacting with machines across the industry, you need to understand the safety principles of machine operations. And the first thing that you need to actually notice that what you should, as a worker, be able to know the proper PPE that you need to use when you are working on a particular machine. Either you are carrying out maintenance, either you are operating it, PPE is actually what applicable. I have seen where people take a lotto on the, I'm going to be sharing some of these experiences, where people take a lotto, that log out on a particular machine, and properly they are working on the machine, they are carrying out maintenance. But the lotto expired, the boss didn't cover up, he didn't finish what the maintenance, and he was reluctant to actually go for another lotto, because he knows that what is going to be sanctioned for it. So what do you want to do? He wanted to use the subordinates so that what they can quickly do is like, they are performing maintenance on a live machine. Okay, the machine just broke down and they quickly want to do a fast job on it. So the subordinate didn't know, the junior engineer didn't know, but the senior engineer had to be what, and he was an Indian man who was just telling him what to do and everything. And it was only God that saved his life, because on the spot the machine was started, because this is a company that is fully automated. So they started the machine from the control room, and had it been it's not for God, another thing could have happened to him. So safety principles is very important, and the first thing is that what you must know the correct PPE to use. In most of our maintenance, we use gloves, whether you are working, whether it's electrical work or mechanical work. Glove is applicable. Okay, safety glasses are applicable. The earplugs are applicable. If you know that what there is going to be a large noise, especially those that are mechanical among us that do mechanical maintenance, clinging of metals, some will be using hammer to actually bring out a particular nut or anything like that. These are noises that when you expose your eardrum to them, over time, we call it ergonomic hazard in safety. So you will begin to lose a good sense of hearing. You will not know. It is just an accumulated hazard, okay, that will affect you in the long run. So another thing is for you to keep loose clothing and long hair, tied back. This is very important. I have seen people across industries, while visiting on inspections, and even those where I've worked before, they will remove their coverall. They will remove their hand inside their coverall, and the hands, the sleeves of the coverall will be dangling. Okay, it should not be hanging around their waist. Trust me, if you move around a conveyor belt like that, and unfortunately for you, if the conveyor belt should get entangled with just that sleeve of that your coverall, that is all. Because it's either you pray that the coverall should tear, and then you get loose from the machine. Like the machine should just tear the cloth so that the cloth will tear off, and then you become free. But if that coverall is made of a good material that it could not tear, trust me, if you have seen where a conveyor belt accident happened before, you will never pray for such. So it is good for you to know that loose clothing will lead to entanglement. You do a long attachment, that is not for you to move around the factory. Whether you are in the machine session or not, once you are entering the factory, the sense of safety should actually come into your mind. So you pack everything well. I recall that then we have a general culture. You will not see a good factory engineer or a good factory worker or industrial worker who is actually interacting with what machines, wearing things like jewelry, chain wristwatch and all that. Because all these, the machines can actually what? Entangle with them. And if you're an electrical person, that is metal. Metal around you can actually what? Be so dangerous for you in case of what? Contact with what? Exposed wire or anything like that. Another thing is about, we call it housekeeping. Keep the work area clean and what? Organized. It's very important. It's part of maintenance culture. I recall then my boss back then in Dangote, he has his own personal toolbox. And what this man does is that anytime we are going for work, because he believes in his own toolbox very well, everything we are looking for will be there. But sometimes, because of poor maintenance, so people will carry the company tools where they will go and work, they will forget that 13 spanner, they will not pack it into the box. So they will forget 13 spanner on the spot, and that's how we will not see 13 spanner again. They may go another day, they will forget the socket spanner. They will not put it in the box. So you will just carry the box that you want to go and work. You get to where you want to work, you see that you need a socket spanner. You look for it, you can't find it. So that's why my boss, anytime he's coming to work, I enjoy working with him a lot. He will bring his own personal tools. So we don't even normally touch the company tools. We'll pack it. So because it's his own personal tools, this is his rule. No matter how tired we are, after resolving the fault and everything, trust me, you will clean the tools one by one. All the oil, all the dirt on it, we'll clean it one by one, set it inside the box properly, then close it before we can leave. That I learned that from him because if you don't pack that tool very well, it's going to actually tell on your next job that you're going to have. You can imagine you looking for 13 spanner and then you cannot find. And the company is actually they are shouting. You are receiving call from the walkie-talkie. They are shouting the name of electrical. There is that time to bring up these machines, and then you couldn't do anything just because you do not have the tools. So you try as much as possible to get yourself organized and clean the environment and clean your tools. Be aware of your surroundings and avoid distractions. This is part of maintenance in industry. Avoid distractions. When you are working, especially those that are, that's why I said that you have to understand the hazards that is attached to the machines. If you know that the machine that you are operating or that you are working on, it has a tendency of cutting any part of your body. Why should you be distracted when working with that kind of machine? When you know that if you forget your hand inside it, like those people that work in printing press where they will have to cut all these log of paper and all that, if your hand is inside that thing, this blade will cut it like a piece of paper. It won't be hard at all. It won't even feel the load of your hand in there. So you avoid distractions while working on machines. Now let's move to talking about machine setup and preparations. It is always important that every machine should be well assembled and installed. I've seen this problem across industry, where you will have there are some electric motors that the stand where they mounted them on is already shaking. So just imagine that this electric motor is actually driving a bed. So if it driving a bed and the base is not rigid, what do you think will happen? It will increase the vibration. It will affect the alignment of the belt. And that is why when we are talking about the installation is different from being well assembled. So a machine should be well assembled. It's just like you fixing a bulb you fix a bulb on a lamp holder that is not screwed. Of course, you may not have correct illumination because the lamp holder may dangle in an angular form and it will not give you correct illuminations. So I'm using that so that domestically you can relate to what I'm talking about. So you have to, or you want to drive your car and the bolt are not tight. The bolt of the tire, you did not tight it very well. Okay, so it has to be well assembled, and aside that, it has to be well installed. every machine needs to be what? Well installed. Before you even talk about maintenance. Maintenance starts with what? You putting the machine what? In a good what? Form by correct what? Installation. And what do we call what? Correct installation? I don't know. In your mechanical, and everything, you can look at your field. Are you able to spot some of the machines that you can see that they are not well installed? It starts with that ability for you to reach a place, because they can call you for a machine failure, and then the actual problem might actually be that the machine itself is not properly what? Installed. That might be the problem. So every machine should be what? Properly installed. Another thing is that what? Make sure that what? You follow the manufacturer's instructions for setup and calibrations. There are some machines that they normally what? Have to calibrate them before I have this experience when I was working in the telecommunication industry. There was a time they wanted to change all our generators. They wanted to change all our generators from AC gen to DC gen. Okay, and why are they changing them to what? DC gen? Because our company actually partner with with another company which is into what? The generation and the building of this generator. They actually built them here in Nigeria. So we don't know the condition of the partnership, but they wanted to change all our generator in our site. All these MTN masts that you normally see around. That's where I work. I have about 28 under me then, and they have to change all this generator. Now the problem we had with this generator is the calibration, because you have to set everything, the temperature, the tripping temperature, everything. It has a panel on which you have to set everything predetermined. There is a predetermined temperature you will set that, if the temperature is hot to this extent, the machines actually was shut down, because you want to protect, the machine itself. It's just like your car, okay? These are sensors. So if your car heats up to a particular temperature, that definitely the manufacturer know that it will cause a very big damage to your car. What will happen? You will see it there. That is actually the temperature is too much, because it can lead to fire. So the proper thing is that you have to shut the car down. So if you do not follow the instructions of the manufacturer in the calibrations, you begin to have issues. You will just be seeing that there will be failure. The mean time before failure will be low. We're going to calculate all that tonight. So when you see those calculations, then you understand what I'm talking about. Because those things would have been cited by the manufacturer for you to know the reliability of the machines. So you may think that the machine is not reliable if you do not follow the calibrations. And so people normally do that. They say that the cutoff temperature, maybe the cutoff stage of this is that whenever 20 ampere of current flow through this thing, it has already become overload. So instead of you to actually leave it like that, the machine should trip at that current. So people, because they want the machine they want to run that machine. They want the machine to actually do the job. What will they do? They will set it to 25. You can imagine. In the manufacturer's specification, he's putting 20. You set it to 25. So the machine that's supposed to trip when it is already maybe 20 degrees Celsius or 20 ampere of current, we'll see 20 ampere as a correct consumption, and we continue running until it now reach 25. Whereas the manufacturer know that if you run it beyond 20, you would have the machine damaged. You will not see a machine that have that normally operate before the downtime. Maybe it normally operate like 7 hours. Lifetime will not be reducing. It will not be able to meet up with 7 hours again. It will be meeting up with 5, and then before you know it, the lifespan of running of up to 5 hours will reduce to 3 and all that. These are part of the problems, that we normally commit when it comes to following the calibrations, being instructed by the manufacturer. Another thing is that you hardly see a machine that does not have moving parts. We hardly will you see a machine. Hardly. I'm talking of, in fact, even except the one that is not using electrical, if it's not using, hardly will you see across industry. Okay? Even if it's not using that, if the actual machine is not using that, the motor that is driving it, that machine is using, it has what moving parts. And that is why, you know, when it comes to lubrication, when it comes to you checking what the fluid levels of what of machines, you have to prioritize it. Checking the oil, checking the coolant. I will tell you a lot of horrible things that I have seen across industry, and people will think that they are smart. Manufacturing, they already told you that what in every 10 days, they did not say top up the oil. They said change the oil completely. You will see our Nigerian engineers, what will they do? Rather than for them to change the oil completely, what they will be doing is to be checking the viscosity of the oil. They say, the oil is still good now. The oil is good. Whereas the company has released what? The oil they're supposed to use to change. They're supposed to change into that machine. Okay? So they will not be touching that. The oil is still okay now. What they want to do, they want to sell the oil. So instead of them to change the old one that is there, they will top it up. And you top up the oil, okay? Meanwhile, not knowing that what there is a lot of work that oil is even doing. Aside from being serving as coolant, there are some machines that what they are being washed by the oil that you even put in them. Because of some parts where dirt must not actually debris, broken, you know, due to wear and tears that might have happened, all those filings that must not get to some part of the machine. So when you put correct oil, okay, and you follow it, definitely the machine, aside from being operating at normal temperature, it will also be working without dirt, being clogging. It will affect or it will avoid some clogging of dirt, you know, in some part of the machine. Another thing is that we need to actually ensure that all tools and accessories are properly attached. When we're talking about this, we are talking about you checking the bolts and nuts of every machine and make sure that they are well tightened. You know, many of us, when we use our four-way spanner, you know, I'm giving an example for those people that drive among us. If you use it on your car tire, you are tying it down. Why is it that after you have used your strength to tie it down, some people will still use their leg. You know, they will use it on that four-way spanner to ensure that is well tightened because they know the repercussion. God forbid, of your tire bolt, you know, getting loose while you are on speed. Of course, it's a terrible thing that nobody pray for. So when you are using the machine, every part of the machine that should actually be joined together must be properly tightened. All the accessories must be attached, well attached, compact. Okay. Before you run your machine, conduct a trial run so that you can ensure that the machine is actually working fine. Before you even load it, that's what we are talking about. Before you load the machine, it is good that even a machine that you operated yesterday, before you load it today, power it up as an operator. Is a normal way for you to actually welcome the job to another day. Power it up, let it run, let it just warm up. Okay. Now, what will this allow you to do? It will allow you to listen to how the machine works on no load. Because there is a way you will listen to the or observe the way the machine actually sounds when it is on no load, okay, and when it is on on load. It will tell you that maybe something is wrong. When you run it on no load, you'll be able to hear some clinking sound that may show whether some parts are actually touching or noise and all that. When you load it, you may not know. Well, you think that it is because you have mounted load on it. But when it is on no load, you can easily pay attention because it is not loaded yet. So if there are some unusual noise, definitely you'll be able to spot it out. So it is imperative for us to now discuss operation principles. Now that we have exhausted pre-operation. When you are starting your machine, please, a machine should be started according to the manufacturer instruction. Many people don't follow this. Except if you read your manual. Let me give you an instance. I've started my car in the wrong way, many times without number. Before I actually saw it that I was doing it in the wrong way. Is it through the manual or somebody actually talked to me about it? Many of us, if we want to start our machine, our car, let me give an instance. You only just take the key, Once you put the key in, and I'm just giving you an example that every manufacturer, they have what specification on how what a machine should be started. But many of us, because we just know where the power button is, you just think that you can just power up the machine anyhow. Of course, the machine will work. But what you will not know is that what you are damaging the lifespan of that machine. You will not be able to achieve it. You won't be able to achieve what the lifespan of that machine. So when starting my car, I only take it from what? No ignition and to full ignition within no stopping. But the key is supposed to have been taken to a partial start. It may just be a transition time, but you have to take it to the partial start where the light will only come up. The vehicle has not, the engine has not really started. It just be like when you take it to that word partial start, your radio, your all those electrical gadgets can actually work before you now take it to full ignition for the engine to start. But for me, over time, I will just take it like that, just to full ignition, and then what will that actually do? It will your brush. It will affect your brush. It will affect your kick. Okay, over time, you will not know that you actually causing damages. Whereas most things that happen, it is because of your lack of maintenance, good maintenance culture. So every machine, you must follow how to actually start a machine. It's very important. There, for example, there are some machines that you must not start on load. You have to start them on no load. In fact, most of the machines. So you don't start the machine when it is already loaded. When there is no load attached, then you start your machines. There are many people that they will have changed their generator down. They have already changed their changeover. They have changed it to what? To normal gen load, and then they go and start generator. So what are they doing? They are starting the gen on load, and that we have the machine. The generator may struggle, start and pick up, no problem. They will think that they are smart, but over time, it will affect the lifespan of that gen. That is what most of us do to industrial machines. So when starting the gen, what's the normal starting procedure? It should be on no load, so that it will start and run free. And then before you even walk to where you're going to change it over, at least 1 minute, it has already run for like 1 minute. All the flux, the magnetic flux have already been built up properly. And then you change it to load, you see that it will stabilize. And when stopping your when you want to put off your gen, it is also normal that you should also put it on no load, okay? Remove the load and then go and stop it. So people will still stop the gen while it is still on load. I'm giving you an example of that. So you need to start the gen or start your machines, in line with the instruction of the manufacturer. Then you monitor the machine's performance. When you have started your machine and it's not working, it is very imperative as an operator or as a worker that is interacting with that machine to not leave your machine to just be running. Pay attention, okay, to the way it's working to know whether there will be some adjustment that you have to actually do. For most of us that go to these guys that normally grind their pepper, you will see them, okay, when they have started the grinder, it might be working. At a time, they will be adjusting so that they are listening to the sound. You will leave it to a machine that is actually struggling. You will know that this machine is struggling to work or is forcing itself to actually work. So there may be some adjustment that you need to actually do. Okay, so avoid overloading or overworking your machines. This happens in so many industries. Okay, overloading and overworking the machines. You just want the machine to continue running. I've given us an example of this. Okay, it is very, very important that you do not overload machine. If you think that you can do that, what will happen is that it will affect the lifespan. It's just like human being. If you are carrying the load that is more than you, of course, you know that you are damaging your system. You will damage your system. We do this in economic hazard. For those that normally bend down to carry load, bend down and carry load, bend down and carry load. Whether you like it or not, over time it will be as if they have hunchback. And that's the effect of what they have been doing, for a very long time. Okay. Maintain control of the what machines all the time. Make sure that what you are not out of the control. Don't really be out of sight. Okay, you should know how long you can leave a machine to work, and not that you start your machine and then you are gossiping with a fellow employee, and then you don't know that something is already what's going on. So let's talk about the control and monitoring of machines when you are operating your machines. Okay, you monitor what you need to understand the machines controls and instruments. It is very important. What are the control on your machines? Does it have a thermometer? Does it have a pressure gauge on your machines? So that you can actually monitor all these things. The speed of your machines, okay, the temperature of your machine. Like I was using the example of your car for you. Of course, you hardly see somebody that is actually driving. Yes, it's not good for you to be looking at your dashboard. But sometimes, many of us, you just glance at your dashboard. You want to really see. Either you are looking at the level of your the gauge of your fuel, and while glancing at that, there's no way you will not see the temperature meter. Okay, or you want to look at how much of speed are you on. So you want to check. You glance through most times. That's exactly what I'm talking about. The machines. So you need to actually know the temperature, the allowable temperature that your machine is allowed to actually run on, the pressure that the normal temperature that the normal pressure for your machine, and all these will help you to actually know when the machine is malfunctioning and when it is functioning properly. So this is very, very important. Machine settings should be adjusted until you have an optimal performance. It's very important. One of the things that you need to watch out for while you are using your machines, especially when you are performing maintenance, is for you to check the wears and damages on the machines. Checking these will actually help you to know if there is a problem, because over time, the machine might be managing to actually to perform work. It might be functioning, like forcing itself to function, but there will be breakdown along the line if this is not actually being put in place. You must also get yourself familiarized with maintenance and troubleshooting of the machines that you are using. For example, the cleaning of your machine, regular cleaning and lubricating is part of your maintenance. So there is no, hardly will you see a maintenance, a procedure that does not involve cleaning. Many of us do it a lot. I've seen mechanical guys performing maintenance on machine before. Most of them also use blowers. They use this compressed air blower. They use it to blow. What they do, they use it to blow dust. Electrical guys carry this a lot. In fact, there's a maintenance that you have sometimes back then in the industry. Sometimes then I used to have this feeling that how are we going to trek this far? Because if the operational vehicle is not available, you will trek. How are we going to trek? We may trek, climb stairs just because we want to go and check on a particular electric motor. And the only thing we will do when we get to this electric motor is that, because I work in a cement plant, so the only thing we will do when we get to this place is that we want to see if the dust or cemented dust has covered the control panel or covered the push button or covered the terminals and everything. The only thing we'll do might just be to plug the blower and blow the dust away. That's all. So sometimes you just go and do that on operational check. You just want to check as the motor is operating or the machine is operating, and then you just you want to clean it. So cleaning is part of maintenance is very key. Lubricating, okay, is part of your maintenance and troubleshooting. And then you need to also understand that while you're actually carrying out maintenance, you need to also follow documentation. I'm going to talk about this. Documenting things that you do, the issues that arise and all that. Following the manufacturer's instructions when troubleshooting a machine is very important. I recall then, the first thing we will do when a machine breaks down back then is that we will bring out the manual so that we can check the connections, the network diagram of that machine. So it will help you to know where to actually go. So it helps in the case of maintenance and troubleshooting, especially when you have what a machine that has already broken down, which has run towards failure. Shutdown and storage, I've made mention of this. Every machine also has a way that you can shut them down. I gave you an example of your gen at home. When you're shutting down your gen should actually be shut down on no load. Not when it is loaded. You have to shut it down. There is something I really want to achieve this night, and definitely we have to achieve it. That will now show you, if you have even been performing maintenance. Many of us don't know there are some machines that you see that it's every 3 days you go and perform maintenance on them. And there are some machines that it takes you 10 days for you to go and perform maintenance on them. Why? And as a person, how will you even determine on your own to know the proper time to actually check on the machine? That's what I will achieve tonight, in the long run, through the calculations that you need to actually understand when it comes to machine maintenance. There are some calculations you need to understand, and they are very simple calculations that you need to know as an engineer, as a maintenance engineer. I'm just pushing that to the latter end of my class tonight. So this night I'm giving you the overview, okay, of what maintenance is, and then so that the practicals can actually begin. Practical illustrations and demonstrations can begin as from tomorrow. So this leads us for us to now talk about the importance of maintenance across industry. Why do we have to actually perform maintenance? I've mentioned this, but let me briefly mention it again. Now, we perform maintenance for the sake of reliability. No one wants to work on a machine that is not reliable. For example, if you have a machine that normally shut down every 30 minutes, is that kind of machine good for operation? Of course, it will affect operation. There are some machines that I will tell you that I've worked in industry. There are some machines that run for days and weeks without shutting down. If you have worked in the cement industry before, you will know a machinery called kiln. Okay, KILN. The kiln will run, for weeks. It will run for weeks because the maintenance of kiln is not a small maintenance, because the temperature inside the kiln is about 1,450 degrees Celsius. Do you know what that is? 1,450 degrees Celsius. So anytime they shut down kiln, they shut it down. 4 days, we have not even gone near it. It's still cooling down. It will be cooling down before the personnel could even say they want to go in, because most of the problem inside kiln is that the bricks layer there, one of them might have removed. Of course, you'll be seeing it because of the control around you will be showing you that there's a problem. So they will run it to failure. They will run. There's sometimes that you run a machine to failure, like until it fails, so that you can perform the maintenance on it. So you can imagine a machine that it will take you like almost 8 days to bring up anytime it's shut down. Just imagine that machine being a kind of machine that anytime you will use 8 days to bring it up, and it will use 3 days to run and shut down again. Is that an effective machine? That's not an effective machine. We don't need that kind of a machine across industry. But every industry will want a machine that can run for a long time before it actually breaks down, or before it may be purposely shut down for maintenance. So we perform maintenance because of reliability. Efficiency also. When you don't perform maintenance on most of these machines, they consume power. When there is friction on the machine due to improper lubrication, what will happen? Of course, we all know that friction is an opposing force. The machine will be drawing more power than necessary, and there will be a higher power consumption, because there is a higher friction on the moving parts that you have not lubricated well as a maintenance engineer. We also perform maintenance because of the longevity of a machine. You really want to increase the lifespan, or you want to maintain the lifespan of a machine, because without proper maintenance, there is no way. Okay, it's just like you as a person. Just imagine you are not maintaining your body, you are not taking your bath, you are not brushing. When you have a headache, you don't care. When you have stomachache, you don't care. Will you be able to live the lifespan that you're supposed to live? That's what happens to a machine also when we don't perform what maintenance what on them. Okay, so it is very important that what good maintenance also help us for what cost savings. You will save cost because in maintenance we can properly say prevention is better than cure. A machine that what you will lose as a company when the machine will fail, that's the downtime it will cost. It will cost you more than what you spend on the maintenance. That's why you see that company don't joke with it. They say that there are some engineers that are actually doing a dubious thing on the machines. They will give you the oil because they don't want you to give them an excuse. You will explain yourself what happened to that machine when it runs to failure or when it fails. They will give you every month. Is it that some of them don't know that what? Some engineers they don't use the oil as lubricant. They don't finish the oil. Some of them will top it up. You think that they don't know? They know. But it's just for them to hold you responsible. So the company want to reduce cost because downtime will cost them more than what maintenance will cost them. Good maintenance will also help us to improve our safety. We have gone through it. Increase productivity, reduce downtime. The lifespan of the machine will be it will improve the quality of the product when we actually perform maintenance. And also it will make our environment to be friendly. Because when the maintenance is not properly done, trust me, you have some machines, they will be emitting out will be poisonous gas and all that. But by proper maintenance, the emissions might actually be reduced. Okay, you may be able to control energy consumptions and all that. Briefly, let's now achieve the latter part of this class tonight. In some ways, you will see that we have different aspects of maintenance across industry. So I've specifically map it out that this night I'm going to cover that. Now, the first one that I want to discuss briefly is preventive maintenance. They are not hard for us to really understand. What is preventive maintenance? Those are the scheduled maintenance. There are some machines that have been scheduled. They are working properly, but every three days, they will be shut down for maintenance. There are some machines that nothing concerns us that they are running. So that you'll be wondering, why did they have to shut it down? Maybe it's working. You will understand when we do the calculation. Every 10 days, they will shut them down. This is preventive maintenance. What is it preventing? We are preventing failure. We don't want the equipment to fail. We don't want to wait until it fails. We don't want to wait for fault. We are dealing with prevention is better than cure. So they are scheduled. As a maintenance personnel, this machine should be maintained every 3 days. You see some of them, they will just go there, they will not do the proper thing, they will not lubricate, they can just blow the dust and then they will leave. Whereas what it is itemized for them to do on that particular day is for them to maybe lubricate, retighten the bolts and nuts on the machines, check the alignment and all that they're supposed to do. Some of them will just do it because they want to return to office and be discussing. Corrective maintenance would occur when we now have failure on the machine. Now this machine has failed. We have to repair the machine. So the repairs that we carry out on the machine is what we term as corrective maintenance. We are now correcting our error. We are correcting the failure of the machine. So when we run the machine, when the machine fails, just suddenly fail, then we have to repair it. It might be a broken nut. It might be the bed actually caught. It happens, even for those who that drive. So that's corrective maintenance. Predictive maintenance. Okay. I was explaining about sensors and all that earlier. Maybe you are running a machine. The machine is still working perfectly. But you see that on the sensor, perhaps maybe on the temperature meter, you see that it's showing a higher temperature. Like the one I gave you as an example of your car. And you say that it's doing overheating. In most cases, when some cars are doing overheating, they are still moving. They will still be moving. It's not that it will not move. But you know that when it happens, I've experienced fire outbreak on my car before. So I could relate. Okay, but that one was sudden. But this one, you may practically see that one, maybe the heat is building up. Maybe the fan, the cooling fan are not working and all that. You have to shut down what? The car. That is what? Predictive. So the predictive is not based on your sensors. You look at your sensor, you see that what the result, the reading they are giving you is not really what? It's not really good like that. So we have to shut down the machine. Because we are already predicting that what? Failure will happen if we do not do this. So that's predictive. So we are predicting. You are envisaging. Okay? You are already having an overview that what? Oh, expectation that what? Failure will definitely happen. So let's shut it down and what? Do the needful. Before the what? The machine actually will fail on its own. And then we now have condition-based maintenance. What is condition-based? Condition-based, sometimes some people mistaking this for what? Predictive. Predictive has to do with what? The sensory aspect of the what? Machines. Let's say that what the sensors and what the controls are telling you, or the data analysis around the machine. But this condition-based maintenance has to do with what? The physical condition of the machine. There's sometimes that as somebody that inspects what? Machines, like that my friend that told me that what she goes to field to inspect. You may see a machine that is still working, but maybe a part of it is just dangling. You can tell them to shut it down and tighten that place. In their own mind, it will not affect the machine, it's still working. You tell them shut it down and tighten this thing because the condition is not looking good. So that is what he has the four, basic. So you see some people saying that, oh, maybe we have more than, but these are the four basic of what maintenance. We have what preventive, we have the preventive, we have the corrective, we have the predictive, and we have the condition based. It is very important, okay, because of when you are actually attending to some of the assessments, you show whether you have followed this training or not. Now, I will discuss the best practices, okay, briefly. What are the best practices for maintenance? Okay, it's good that you develop what? A maintenance work schedule. Like I've explained, there should be schedule on the machine. If we perform this maintenance today, when is the next time that we are going to perform this maintenance? So a schedule should be what? There should be a schedule maintenance, which is what? The preventive that we have talked about. It's also good that the maintenance guys should actually be trained. I've explained this. It is also good that we should monitor the condition. That's the best practice. Monitor the condition of the machines. And it's good to also implement a computerized maintenance management system. We call it CMMS. Computerized will actually let you know, you'll be able to actually see it electronically that these are the schedule of our maintenance. This is the last time that they maintain this machine. Many companies are not using this, and it's very, very bad. They do everything manually. And it makes most of these maintenance guys to actually escape doing their job. The CMMS will show you a machine, the last time it was maintained, who actually carried out the maintenance, when is the next time it's going to be carried out, and who is actually assigned for that maintenance. So it's kind of giving us the inventory and the work orders of maintenance on the machine. This is a very good practice when it comes to maintenance culture across industry. When a machine actually shut down, do not just jump into repair. Perform a root cause, a root cause analysis. I will see maybe during this course it's a course on its own. Okay, we did it under our critical thinking course. There is a course under us that is called critical thinking. This is where you learn about root cause. People jump into conclusion. They can just look at the machine and say, it's the temperature that is high, just put oil. Whereas it might not be the oil that is actually the problem. What people will not know is that something actually must trigger the hike in that temperature of the machine. It might not be oil, because if you check the oil level, the temperature is high. You now check the oil level, and you know that the oil level is okay, but you are topping the oil. Whereas when you are dealing with oil, in most of the machines, you will see low, you will see high. Okay, they will draw it there. You will see low, you will see high. That is this is how low the oil level should actually go. This is how high it should be. So even we top it up, thinking that maybe it's the oil, or they will start putting water and everything like that. So you need the root cause analysis will let you know deep down to what is actually affecting this machine. So maybe there's a particular part of the machine that is not functioning well, that is triggering what? The hike in what? Temperature. Continuous monitoring of machines, I've actually what? Explained this. Now, what are the consequences? The consequences of poor maintenance of what? If you are not performing what? Good maintenance. They are not far-fetched from what I've discussed tonight. Equipment failure, you will experience it a lot. Safety risk, you can receive shock. It can cause somebody's hand. If there's a blade that you did not tighten well, very well, can give you a cut. It can affect you. It can injure you. Even if you think that you are conscious of it, that you will always run away from it. And there will be a day that you become unconscious. You will not even know, and your hand will go there. Environmental impacts, emissions. You don't properly take care or maintain your vehicle. You see them on the road. You know the kind of carbon monoxide that they actually bring out. But you will see some cars, they will be walking so cool. They will be moving fine. You will not even know that what exhaust is coming out of them. And you see some, when they pass, everybody is actually causing what the driver or the car owner. Some machines are also like that. The way, because of their maintenance, the maintenance will show. The emission can show us if it's actually poorly maintained or if it's properly maintained. Reduce productivity, increase cost. Of course, you will spend more on that particular machine if it's not properly maintained. All right. Yes, I want to. So let me see my. So I will talk about the tools. You know, I will begin with the tools tomorrow. I will talk about the safety tomorrow. So tonight, let's talk about the maintenance metrics. I will end the class with maintenance metrics. I can see the moderator is already signaling at me. So let me just discuss the maintenance metrics. It's very important because I really want to achieve that. Okay. Now, what you must have had most of these terms, and I want us to kind of within few time break it down. So you'll be hearing something like mean time before failures. What do we use them for? Why are they so important for us in industrial maintenance? Okay, mean time to repair. You hear all those things. Okay, mean time before failure. Mean time to failure. Okay, so let me explain these three. Okay, I will share my screen on another device. I will share my screen on another device. Okay, I think I'm sharing already. Can you see my screen? You can see my screen?
Yes, your screen is up.
Okay, yes, thank you so much. All right. So, yes, thank you so much. I can see somebody giving me thumbs up. I like thumbs up. Oh. They give me joy. Okay. So let me explain.
Sorry, okay. Your screen is not visible here, sir.
Yeah, your screen is not showing. You can't see what's on your screen.
You can't see my screen?
Yes, sir.
No.
Yes, sir. We can't see your screen.
Your screen is not showing.
We can see your screen, but we
see blank. Your screen is showing blank.
The screen is showing, sir.
You can't see me writing on the screen?
I can see a whiteboard, but nothing is.
Yes. I'm using whiteboard actually. I just want to explain MCCR. Okay. That is a mean time. We call it mean time to repair. You know, so people will use this R can be to repair. You can see to resolve. Some people can call it to what? Respond. Okay. We also have what we call MTT. MTBF. Okay. So mean time before failure. Okay. We also have what we call MTTF. Mean time to failure. Okay. Mean time to failure. Okay, so let me first tell us what we use this for, and then the calculations. I think I will have to begin tomorrow's class with the calculation. But I want to tell us the beauty of this. Now, what is the beauty of this? Now, mean time to repair actually is a measure that industry use to know how responsive their team is when it comes to bringing up a machine after it has what? It has what? Failed. I hope you are getting my point now. Like a machine actually what? Failed. How long, if our machine fail, how long will it take our guys, our maintenance guys, or our operation guys to bring this machine up? Let's say they want to perform any repair on it. How long will it take them? Is it 5 minutes? Is it 1 hour? Is it 2 hours? This will give you an idea of how reliable our team is and how fast they can bring up a machine so that our production will not be affected. So that is what we use, mean time to repair. You know, you can call it to repair. That's how you can see to repair, to resolve, to respond. They all mean the same thing. So it is still what? MTTR. You know, in cyber, aspect of work, you might have seen this a lot. Let's say somebody actually hacked into our system. How long does it take us to regain our system back, to recover? That's MTTR. Okay. If our machine shut down now, how long will it take our engineers to bring it up? That's MTTR. Every company actually has this, and in most cases, it is peculiar to what each machine. I'm going to be giving you calculations, calculated examples. We can even bring, you know, some of you can actually interact with me and bring some. You will use the machines that you are working with, and we are going to calculate for you to see that, oh, this is how you will know how reliable that machine is, and that will actually guide you on the proper maintenance on that machine. What about mean time before failure? Mean time before failure, by the time you calculate it, you will know that this is the time that we know that a machine can run comfortably and successfully before it actually shut down. There are some people that do not pay attention to this, but companies don't joke with it. We want to know how long a machine will run before it will fail. That if you do not touch it, it will actually what? Fail. So imagine a machine that you know that what? If it runs for 3 hours, it will shut itself down. No matter what you do, after 3 hours, this machine will fail. That's why you see that what? Company will never joke with it. They will say every 2.5 hours, they will tell the engineer that they must perform what? Preventive maintenance. Do you see this now? This is the calculation that we do. That's why you see that what? There are some machines, every 3 days, they will shut them down. They are shutting them down based on their what? MTBF, mean time before failure. Because we know that what? If that machine run and exceed 3 days, it will shut down, it will fail. So instead of it to fail, they will say purposefully shut it down. Maybe the MTBF of the machine is 4 days. We are going to say that what? After 3 days, shut it down and perform maintenance on it. When you put it in order, then it can run for another 3 days before we shut it down again. But if it should fail on its own, you know, it will damage some of the part of the machines, and that will take us a longer time to bring up. So the maintenance will cost us less than the downtime. So I will show you how that calculation is actually done, you know, from our next class. What about mean time to failure? We want to see what is the lifespan of the machine. This is what this one will tell you. The lifespan of this machine. We normally use this to determine the lifespan of the machine. There's a machine we know that no matter how you maintain it, it cannot serve you more than 5 years. How do we calculate this? It's also based on calculations. So you have those machines in industry. You that you are working there may not know. But if you have the knowledge of all this, you can see that there are some machines that, whether you like it or not, they will just say, okay, they are installing a new one, they are replacing it. In your own mind, the former one is actually working, but you will not know that definitely they already know the MTTF of that machine. And instead of you to actually wait until it fails, you know that there's a machine that once it spends like 5 years, it is better that you replace it with a new one, because the lifespan has already said by the manufacturer that it will only last for about 5 years in good condition. I normally advise people that do our safety course. I'll say, okay, fine. Whether your helmet is okay or not, once you use your helmet for 3 years, change it. Your safety boots, no matter how good it is, I maintain the ground that what you should at least try to change it yearly, or you have more than one that you are using that you can be using interchangeably. Depending on even where you are working, that can weaken what you are using as PPE. So there are many PPE that they may be looking good. You know, I even have some some industrial workers that will go and repaint their helmet, which they do not know that what the adhesive that they are using on the helmet will weaken it again. So these 3 calculations are very important for us if you must understand industrial maintenance. And that is why you must not miss that calculation, so that you will be sure, certain that when you are dealing with a machine, you will know why a machine is being shut down 3 days after operating for 3 days. They will shut it down for maintenance, and some they will run for like 10 days. They will shut them down. That is because of their MTBF, mean time before failure. And for us to know how long it will take us to bring up a machine, we calculate the MTTR, mean time to repair, to respond, to resolve. And for us to know the lifespan of a machine, we calculate the MTTF. These are the practical things. Mean time to failure. You know, they do this a lot. If you see the company that are into that make all these bulb that you are using, it's because you don't read the employer. If you put your bulb there, okay, there are some bulb, they will tell you that they cannot work more than 3 months. They will blow. It will blow up. Exactly all those filament bulb. In fact, they are now worse these days. There are some of them that immediately you even put it in lab order. In the next 1 hour, it's already out. Because right now, almost everything is fake. There is fake of every product. It might not even be the company that is making it. So people might actually be making a parallel product like fake of its kind. But when you know the MTTF of a machine, you will not be surprised that you know that, this thing can actually pack up. In the next 3 years, it will be due for me to replace it. So moderator, I'm so sorry for taking a longer time. So let me stop there tonight, and then we'll continue tomorrow. So we'll begin with this calculation tomorrow. Thank you so much for staying in tune with me.
Okay. Thank you very much, trainer James, for that wonderful lesson. So majority might not know that we actually used a recorded session, but so far I believe the training has been fine, has been going well. Okay, so it's time for questions, and luckily we have our trainer here with us. So it's time for questions. So please just signify by raising up your hands so that we can take your questions. Questions. Let me see your hands. If you have your questions. So we'll probably be taking feedbacks. Okay, Christopher Oladoso, thank you very much for our instructor for tonight. Yes, thank you very much for your comments. So please, your questions or everything that has been taught tonight is well understood. So today is just an intro into the whole training on industrial machinery maintenance. So tomorrow we'll dive in, we'll go in depth a bit more tomorrow. So I believe everyone who has joined into this class wouldn't be found missing in tomorrow's class as well. Can we get the material on this and subsequent let me check the message again. Okay, and subsequent training classes. Yeah, of course, we'll try our best to make the materials available for everyone to have access to. So, okay, so it's a good eye opener. Thank you. Okay, thank you very much, Ibrahim Bosari. We love that you enjoyed the class as well. Okay, so anyone with question? Okay, if there is no one with questions, let's go straight to comments. So those who joined us live on YouTube channel, let me use this opportunity to appreciate you all. So please, if you have any further information or you are interested in in the other classes, just stay on our channel. Just subscribe on our YouTube channel. So the live classes, you'll be able to have access to them. So once you subscribe to our channel, you get the pop-up for every live classes that we have. So endeavor to do that. So let me appreciate you all for joining in the class and staying up until now today. So please, for those on the YouTube channel,
I have a question.
Yeah, I'm coming to you. So for those who are on our YouTube live, so please drop your questions in the comment section as well. Okay, so Mr. Yakubu Abdullahi, were you the one I heard your voice now?
Yes, I'm the one.
Okay, please go ahead with your question.
Good evening, everyone, the moderator and the lecturer. Thank you very much for this very insightful and then very educative presentation. I can say I really learned a lot actually. My question is regarding the MTTF, the one that used to determine the lifespan of the machine. There are some, I can say there are some machines that you see that you just be running it for years, for donkey years. I don't know, is it that this formula, the MTTF, doesn't apply to those machines or what? Like, I know like compressors, pumps, motors, such kind of the equipment that you can see that you will just be running them in the industries for donkey years. I don't know, is it the formula does not apply to them or what? Thank you very much, sir.
Okay, thank you very much for your question, Mr. Yakubu. Okay, so Mr. James, are you there with us? But
yes, I'm here.
Oh, okay, thank you very much. Okay, so then let me allow Mr. James to respond to Mr. Yakubu's question.
Thank you very much, Mr. Yakubu. Actually, I would have said maybe we should wait until the second class when we're going to do full calculations, and then you see. But I can relate based on my experience across industries. I can relate with what you are saying, and that's what we are talking about. There are some companies that overload machines, like they run machines like with the way we engineers should treat machines. To us, in biology, machines are non-living things, but in maintenance, they are like living things. Okay, and that's why you see that some of them are actually be shut down for maintenance. Actually, there are some machines that can run for a very long time. Like let me give you an example. I've worked in the cement industry before, where we use kiln, KILN. So a kiln can run for several months, like can run for many months before you even shut it down for maintenance. And when you shut it down for maintenance, the maintenance may last like 1 week or 2 weeks. So depending on the damages that you really want to. In most cases, they even shut it down for corrective, maintenance rather than preventive maintenance. So there are some machines that they run in industry based on corrective maintenance only and not preventive. But when you check it, that is not how manufacturer has actually made it.